Hi, let's look at an example of Kirchhoff's voltage law with both a voltage source and a current source. Anytime that you're faced with a problem where you have both a voltage source and a current source, there's going to be some challenges involved in that problem. Now, it turns out that in this case, it's actually not that bad because this is a single loop. There's really no place for the current to go other than around that loop. So when we see that this 2 amp current source is pointing upward, that tells us that there are 2 amps flowing around the entire perimeter of the circuit. So there's 2 amps there, 2 amps there, 2 amps there, and then 2 amps here. Now that's very valuable information because it allows us to identify what is V2. So V2 by Ohm's law is just going to be equal to I times R. So V2 is equal to the current in that resistor multiplied by the resistance, which is going to be 2 amps multiplied by 2 ohms. Notice, by the way, that this does obey the passive sign convention because the arrow is flowing into the positive terminal. So therefore, V2 is equal to 4 volts. So that's going to make our lives quite a bit easier when we do Kirchhoff's voltage law. Oh, and by the way, we've already solved half of the problem because V2 was one of the 2 things that we were asked to calculate. So the only other thing that we're asked to find is V, which is the voltage across the current source. And it's kind of weird because I made a big deal about how current sources don't care about the voltage. They'll do whatever has to be done to deliver a certain amount of current. And yet there is a certain amount of voltage that appears across the current source, and we can calculate what that voltage is. So let's do Kirchhoff's voltage law. I'm going to do Kirchhoff's voltage law as usual clockwise. So that means that I'm going to encounter the negative sign on the 10 volts. I'm going to encounter the negative sign on V2. And I'm going to encounter the positive sign on V. And so here I'm going to say minus 10, I should say KVL, minus 10 minus V2 plus V is equal to 0. Now, of course, we know that V2 is equal to 4 volts now, so I can solve this equation by moving V over to the other side. V then is equal to 10 plus 4, which is equal to 14 volts. And since it's positive, that tells us that the direction of the polarity that was shown on the current source is correct. That also tells us that because the current is flowing into the negative terminal here, you can see how the current is flowing into the negative terminal of the current source, and it's continuing to flow counterclockwise around the circuit, that it is in fact the current source that is driving the circuit, whereas the voltage source is actually receiving energy from the circuit. So the voltage source is absorbing energy rather than delivering it as it often would.